Under the utilised section of the TI84 CE is the math complex section of the calculator. So I just want to demonstrate a few things to do with complex numbers, polar form and Euler form. So let's choose a complex number. In this case, let's just, for simplicity, keep it as 1 minus I. Well, we can go into math across to complex and we can find the conjugate of it. Arrow up to copy it. There we go. Now we're going to use this complex number several times, so rather than keep going arrowing up and copying, why don't I just store it as a variable? In this case, I'm going to store it as z for the vector. For the complex number. So let's go back into math. Across again, what can we find? We can fill in the real part. Well, we should know the real part of that one is 1. Okay. I said I was going to use z, didn't I? But I didn't that time. And we can also find the imaginary part, which we can see from there is minus 1. Let's this time use z, like I said I would. There we go, minus 1. What else can we find? Well, we've got the angle that we can find. That would be very useful, theta. Won't give, obviously, if the question was that exact, then we'd have to work it out exactly. But we can use the calculator nicely to check what that is. And if it's a nice number, then it's a multiple of pi. So if we take that number and divide it by pi, we'll be able to find out what it is. It's negative a quarter. Let's just see if that's true. And we can see, yep, it's negative quarter pi, so it's negative 45 degrees because we are in radians. What else is there in complex? Well, we can find the absolute, the magnitude of it. So again, let's just use that stored variable that we've got. There we are, 1.41. And again, if it's a nice number, it's the square root of a number. So if we square it, we can find out what the original number was. And there we are. So that's the square root of 2. Okay, so looking good. So we've got the magnitude of this vector, this complex number, or if we look at it as a vector, and the angle. And there's another nice little feature here, that if we did have the complex number, go into math across the complex, we can put it, now it does say into polar form, which we know is the magnitude cis theta, but in this case it will give us the Euler form, which we can see again is this magnitude e to the angle that we had earlier, that was that negative a quarter pi I. Equally, we can convert that back again to rectangular form, which will take us back. And let's see if that's the same as if it was in cis. Well, we'll go the square root of 2, because that's this magnitude. And then cis is really cos of the angle. There we go. 4. Close the bracket. Plus I sine of the angle. And what form will it give it us in? Well, it will give it us in complex number form. We can see it's the same thing again. And interestingly, in this case, it actually gives us that the number is 1. So I hope you find that useful. Thanks for watching.